In this video, I'm going to explain graphical synthesis. Graphical synthesis is a method used in mechanical engineering to design and analyze mechanical systems. Any mechanical systems you want to design, you want to develop the new systems, new machines, then the graphical synthesis or analytical synthesis are using. It involves using graphical techniques to represent the motion of the system and to analyze its behavior. The main goal of graphical synthesis is to design linkages or mechanisms that produce a desired motion or output. It involves selecting the appropriate components and configuring them in such a way as to achieve the desired motion. One common approach to graphical synthesis is to use the 4-bar linkage, which is a system of 4 interconnected links that can move relative to each other. The motion of the system is determined by the way the links are connected and the angles between them. Graphical synthesis can be used to design a wide range of mechanical systems, including engines, machines, and robots, manipulators, etc. It is a powerful tool that can help engineers and designers to optimize the performance and efficiency of their system. The process of graphical synthesis typically involves several steps, including defining the desired motion or output of the system, selecting the appropriate components such as the linkages or cams, configuring the components in a way that produces the desired motion, analyzing the behavior of the system to ensure that it meets the design requirements, refining the design as necessary to optimize performance and efficiency. The graphical synthesis motion generation for the prescribed point. In the graphical synthesis, motion generation for a prescribed point involves designing a mechanical system that produces a specific motion at a given point. This requires careful selection and configuration of the system components to achieve the desired motion. One common approach to motion generation for a prescribed point is to use a 4-bar linkage. A 4-bar linkage consists of 4 interconnected links that can move relative to each other. By adjusting the lengths and angles of the links, it is possible to generate different types of motion, including the desired motion at a specific point. To design a 4-bar linkage for motion generation at a prescribed point, the following steps can be taken. Identify the desired motion. The first step is to identify the desired motion at the prescribed point. This may involve specifying the direction, velocity, and acceleration of the motion. Second, determine the location of the prescribed point. The next step is to determine the location of the prescribed point in the system. This will help to determine the appropriate configuration of the linkage. Third step, select the appropriate linkage type. Based on the desired motion and the location of the prescribed point, select the appropriate type of 4-bar linkage to achieve the desired motion. This may involve selecting a linkage type that produces the required motion, such as a crank rocker or double rocker linkage. Configure the linkage. Adjust the lengths and angles of the links to achieve the desired motion at the prescribed point. This may require relative testing and adjustment to ensure that the linkage produces the required motion. Analyze the system behavior. Analyze the behavior of the system to ensure that it meets the design requirements, including any constraints or limitations. So this is the brief graphical synthesis of any mechanisms, how we are approached to do the uh, desired or basic creation of the new machines or mechanism.